Yeah, welcome also from our side. Today our topic is thermography of chip-level structures with new microscope optics. My name is Thorsten Schech. I'm head of marketing at Optris.
My name is Mike Lippe. I'm an international sales engineer at Optris.
Okay, so and we start. And also at the beginning, I would like to introduce the Optris GmbH & Co. KG a bit. We are an independent, privately owned IR technology company. We are 20 years old. That means we started our business in 2003. We are a manufacturer of non-contact temperature measurement devices. That means we are almost offering the complete range of infrared sensors and infrared cameras. That means we have point pyrometers, and we have infrared cameras, accessories, and software. Our headquarters is located in Berlin, in Germany, but we have also offices in China and in the US, and we have a worldwide distribution.
Yeah, as my colleague Thorsten mentioned before, we have 4 product groups here at Optris, and the first group you can see are the infrared cameras, where we have the XI series and the PI series. And the differences between these 2 cameras, if we switch to the table camera maybe, the 2 differences are the housings. You can here see. So with the XI series, you have a housing with a fixed installed optic, and you have a motorized focus with this camera. With the PI housings, you have a housing where you can choose also different optics, and the advantage here is that you can exchange the optics for different applications. Yeah, for all types of cameras, we provide different resolutions and optics and also temperature ranges, and we provide also different spectral ranges for different applications. The advantage of the infrared cameras are that you get here a complete thermal image. So that means you can see the temperature distribution on your object. You can also create temperature profile lines to see the temperature distributions. You have a hot and cold spot detection, which you can check on your material. And you can also create different measure areas where you can check the temperature in different locations. The XI type of camera has also the possibility to use it in autonomous mode. This means you do not need necessarily a PC. Yeah, you can connect the camera direct to a PLC or also to a measurement unit. And yeah, some types of the XI series has also a direct network connection as Ethernet TCP, Ethernet IP for a digital connection. The second group we have are the infrared thermometers, or also the pyrometers, and they are useful for a spot measurement. And here we provide you small sensor heads with different optics, and also bigger sensor heads with laser diodes, so you can see your spot direct on your material, and you can be sure that you are measuring on the right position. And these groups of pyrometers includes 1-color and also 2-color pyrometers as ratio pyrometers. Also, these pyrometers are available with digital interfaces. Nowadays, Ethernet IP, Profinet, Ethernet TCP IP, Modbus Ethernet, and also for the serial communication. As accessories, we provide you accessories for dusty and also hot ambient conditions. So we provide here air purchase and water-cooled houses. Our cameras can be used in an ambient temperature up to 315 degrees C. And yeah, with the air purchase, we can be sure that the lenses are all the time clean. And we provide you also outdoor housings to protect the sensors and camera outside. With our software, yeah, we provide you complete analysis software, and the software at Optris is always for free and license-free. So that means you can connect the software with all our sensors and cameras to your PCs, to your laptops, and also to your PLCs, and also to your mobile phones. The software is also this is also an open source software, so that means you can also integrate our camera image in your own environment and into your own software.
Yeah, let's dig in a little bit into our topic of today. So what are the challenges in the electronic industry? That means if electronic engineers are making a design for a PCB, it is always a question of design and optimization, because some components get hot during the normal operation. That means they have to take care about heat distribution and think about passive or active cooling design. And very important, what they have to keep in mind all the time is that the lifetime is a function of the temperature. That means finally the lifetime of the whole product which they are designing is a function of temperature, and this is limited by single components like capacitors, sensor chips, microcontrollers, memory chips, or something else. And there is a very famous so-called Arrhenius equation, which gives the connection between the lifetime and the operating temperature. And just for one example, a 10 Kelvin higher operating temperature will shorten the lifetime of components to the half. And this is where we come into the game. That means temperature control is very important. And of course, the manufacturer of electronic components, they specify on their data sheets a distinctive operating temperature. And this needs to be fulfilled during the design of the PCB, of the complete electronics. And therefore, temperature measurement during the design validation is a very important task of electronic engineers.
Yeah, especially for different applications, we have developed suitable types of microscope optics for the infrared cameras. And yeah, one solution, one cost-effective solution can be here the XI400 camera with a macro lens. The XI400 has a resolution of 382 × 288 pixels, and it has a frame rate of 80 Hertz. So it's a very fast solution also. You have here a field of view of 18 degrees × 40 degrees as optics, and 1 pixel size can here down to 81 microns. So this is in a distance of 90 millimeter. And in a distance of 90 millimeter, you can have with this camera a horizontal field of view of 30 millimeters and a vertical field of view of 23 millimeters. Yeah. So we are talking here about 1 pixel. And if we have the MFOV, that means a matrix of 3 × 3 pixels, we have 343 micron in a distance of 90 millimeter. The thermal sensitivity of this camera is 50 millikelvin. If you want to have a more precise image, so if you want to measure more smaller objects, we have here the high performance solution. This is our VGA camera, the PI640i with the microscope optic MO44. And this camera has a VGA resolution of 640 × 480 pixels, and it has a frame rate of 32 Hertz. The advantage of this camera type is that you can also switch the speed to 120 Hertz. This can you do in the software. If you reduce the resolution to 640 × 120 pixels, then you have the high speed of 120 Hertz here. Yeah, we provide this also with a 12 degree × 9 degree optics. And here you can go down to 28 micron in a distance of 80 millimeter. And you have here a horizontal field of view of 18 millimeter and a vertical field of view of 13 millimeters. The thermal sensitivity here is also 80 millikelvin. Yeah, if we go to the next slide, the advantage of the PI series is that yeah, you can use standard optics for electronic boards, and you can also use our microscope optics. And yeah, with the standard optics, you can use here a 33 degree optics or also a wide angle optics. And yeah, with this, you can also check the electronic board. But if you want to use the microscope optic, you can also exchange the optics at the PI series. That means if you have already a PI series, you can choose one additional optic, and then you can order this optic. If you have already the camera, you have to send us the camera, and we can calibrate the camera for the new microscope optic, and then you can immediately switch in the software PixConnect between the optics. Yeah, the optics are here exchangeable. Okay, yeah, the question is all the time, what is the right optic for what application? And we can switch to the table camera. We have here an example As you can see, we have here an electronic board with different types of electronic components and also with different sizes of electronic components. And you can see it's most easier to measure those chips or also those capacitors than very small components like SMD electronic components and very, very small SMD chips. Yeah. And for this, you can see on the slide, we have here some examples. With the XI400 camera, you can use this camera for standard electronic components on the board, and also the PI640 series with a standard optic. You can use it for bigger components, for bigger electronic components on the board to have a good overview. And for sure, you can also use the PI640i with a microscope optic for bigger components, as for example, capacitors or amplifiers. But if you want to measure small electronic components, as for example, SMD components, we recommend to use a more specified camera type. And here you can use the microscope optic with the PI640, because here you have a very high resolution and you have a very precise image which shows you very, very small components in this case. Sometimes it's necessary to go more down and to go more in details of the electronic boards and PCB boards. And for this, we have developed a high-end solution. It's called the PI640i MO2x Optics. So this is a microscope with a 2x magnification. This is also the platform of the PI camera, so the 640x480 pixel camera, the VGA solution camera. And here you can also exchange the optic. So you can choose the standard optic, the MO44 optic, and for the high-end solution, you can also screw the microscope optic, the MO2x optic in front of the camera. And here you can go down now to 8 micron. So this is for very, very small detailed components. And this is in a distance of 50 millimeter, where you have a horizontal field of view of 5 millimeter and a vertical field of view of 4 millimeter. And you have here also the thermal sensitivity of 80 millikelvins. So we are supporting you this microscope optic with a special stand because of the limited depth of field. So with this microscope optic, you must have a special distance of 15 millimeters. And with this high precision stand, you can adjust the camera to the right distance. Here you can also see the overview of all of our optics, but we can have it also in the real picture if we go to the table camera. So you can see here first the microscope MO2x optic, and with this camera you can have a very precise view of very small components as very small SMD resistors and also chips with integrated lines on it, heating lines. So with this you can have a great image. And the second one is the PI640 camera with the MO44 optic. So with this you can go down to 28 micron for 1 pixel size, and with the MO2x optics you can go down to 8 micron as 1 pixel size. This you can see here already in our overview. So you can see the XI400 you can get with the macro optic down to 81 micron pixel size. And the other types, you have the 640 MO44 and the PE640 MO2x.
Okay, Mike mentioned already we have this new camera, and I just like to point out on all images Mike was introducing, we are talking about uncooled thermal imaging. That means a 8 micrometer spot is really on the edge what is achievable with uncooled detectors. Of course, if you use a cooled system with quantum detectors, you can go even further down to smaller spot sizes, smaller pixel sizes. But with an uncooled system, this is really on the edge, which is achievable due to the physics. So we can measure up to 500 degrees. I mean, the technical spec we have seen already, and working distance 50 millimeter. Of course, this is a so-called disadvantage, but this is caused by this 2x magnification we have on this optics. So you have to go very close, but then you have this narrow field of view of just 5 × 4 millimeter, and you need this special holder or special stand for a very precise adjustment of the distance, and with the distance you are adjusting also the focus. Yeah, on the next part we would like to show you some sample images, and we would like to compare our standard microscope just with this new, very sophisticated, high-end 2x magnification microscope. And maybe we can switch again to the table camera. I just want to show you our first measurement object is just a small coin. So this is a dime, so it's a 10 US dollar cent coin. It has approximately the size, you can compare it with my hand, of a 1 cent coin here in Europe. And if you look now back in our presentation, we can see here on the left-hand side, on the left image, you can see this coin with our standard microscope, and on the right image you see it with the 2x magnification. I think this is very impressive. And if we come back to our topic, electronics, of course, then we see here, this is a detector actually we are looking on. That's an 80 by 80 pixel bolometer detector. And with our standard microscope, we are just seeing the entire chip. And if we want to see more details, then we switch to our MO2x optics with 2x magnification. And here you can see, you can even count the single pixels on this chip. Another example is our engineers. Yeah, they were really curious to get more samples. So they were opening an Intel Pentium 1 CPU. And so we have a look here on the die of the chip. And this is the image with our standard microscope. And here you see even an infrared video with 2x magnification. And the automatic hotspot feature is automatically following the heat and showing you the right temperature on small structures of this microprocessor. Yeah, we have also, Mike showed it already, this kind of demo printed board where we just put different sized SMD resistors on. Yeah, starting with a size of 3.2 × 1.6 millimeter down to 0.4 × 0.2 millimeter. And also here you see the entire view of all those resistors with our standard microscope. And on the right infrared image, you see at first the biggest resistor, and this is the smallest resistor here. I mean, this is really impressive. And in our software, of course, in our PixConnect software, you can make detailed analysis with thermal profiles, with temperature time recordings. You can also record videos. This is possible so for detailed analysis later on. And yeah, also here we are closely coming to the end. This is another example, a flex board with also a very small SMD resistor, 0.6 × 0.3 millimeter on the left side with our standard microscope. The right side shows the 4x4 pixel, which we need here for an exact temperature measurement. And also on the right bottom part of the infrared image, you see a small ruler. This small white line is equivalent to 100 micrometer, which is a bit bigger than human hair. So you can imagine how small this is and what details we can achieve with this microscope. Another example, a TO39 package opened here with an infrared heating or infrared emitting source. And I think the images, they speak for themselves. And at the end, just two examples where it is used. This is an example of a PCB design, and also here PCB optimization for proper heat transfer was the task, because this is a critical device later on, and the single parts must not influence other parts. This was very important. And the last is the antenna development. Also here, it's a kind of design optimization. On one side, space optimization to make the electronic as small as possible, and in addition also to make sure that the heat can be transferred in a good way. Okay, yeah, I think we also used a bit more time, but sorry for this, but we are at the end. And again, if you have questions at the end, I hope we have some time.